Hello everyone, my name is Sudhir and I'll be teaching you some CAD or computer aided design over the course of next few weeks. So our aim is by the end of these sessions, you should be able to make your own designs. You should be able to model your own design using any CAD software or at least Creo, which is the software we are going to be using. Uh, in this particular session, it's just an introductory session. So I'll be telling you about like what is CAD and how we are going to work with it, and how can you download the software on your own computers. And if you cannot download it on your own computers, how can you uh, avail it through apps anywhere. So this is going to be some basic stuff which we are going to talk about, and also I'm going to show you like the basic interface of the software. We are not going to be making anything in this session. This session is mostly about like getting you familiarized with the software, so in the next session we can start working. So as many of you would know, CAD is an abbreviation for computer aided design. It's very clear from the name that what you're gonna do over here. So but there's a difference between a design for a layman and a design for an engineer. When some layman would design something or give a concept, they would not look at any constraints or any dimensions. They would just draw it. But an engineering drawing or an engineering design should be in a form that anyone, if they have those design, can manufacture that or replicate that or can bring it to life. There are like so CAD is a vast subject. Like CAM comes under it, CFD comes under it. It broadly it's any program which through which you can create a 3D model or a 2D drawing digitally. So the need for CAD is like if you don't, what if you don't have CAD? What if you don't have Creo or SolidWorks or any other software? And then you are back to pen and paper. So let me show you something. So if you don't have CAD, you would have to do all of this by hand, because there is usually so much detail in CAD drawings which is all important, and you have to make it all by hand. So CAD makes your work much easier regarding to design, visualizing it before manufacturing it, and also for documentation, and obviously for manufacturing, because if you have designed some 3D model in CAD, you can easily create their STL files or G code M codes, and you can 3D print that, or you can just send it to a CNC machine to manufacture it. So CAD is a pathway to manufacturing or visualization. There are like several CAD packages from which you can choose. We are gonna be mostly working with Creo. Everything has its own pros and cons. They like differ from each other in like different ways. For example, SolidWorks is somewhat easier than Creo. Inventor, which is a 3D model making software for by AutoCAD, that's way easier than all of these. But everything has its pros and cons. For example, if you are working in an industry and you have to get a CAD package for that industry, you are the procurement engineer, then you would need to look for all of these things. Like licensing has its cost. Interface, for example, I don't like the interface for Inventor personally. It's a bit difficult. And special features, for example, Inventor's AutoCAD is really good for 2D drawings. Creo is really good if you have to take forward your 3D models to other software for analysis or 3D printing, like and if you are exporting your models to ANSYS or a Abacus. SolidWorks is generally a midway between all. CATIA and things like that, like again powers, and every CAD package has its pros and cons. If you learn one CAD package really good, you would need max of like a week to get proficient in any other CAD software. The major difference is maybe some terminologies or the user interface. The basic working principle is all the same for all of these CAD packages. Let's see what it can do. So this model of a car is made out in Creo. These pictures which I'm going to show you is just to make you realize what can you do in these CAD softwares, because over here in these sessions we are going to stay simple due to time constraints and learning curves. We are going to be doing all commands, but we are not going to be making such complex shapes, but you can do that in your own time if you want to. If you look at these two images, one and this two, you can easily spot some difference. This image looks very close to real life, and even if you look at this image, this looks like almost real. But this image is just a CAD image. This is just a CAD model which is then rendered. So in CAD softwares, you have another option which is really useful. It's called rendering. Rendering is used when you have to showcase your design or your models, or to see how they're going to look in real life. So you make your model and then you're going to render that according to, you are going to set your scene, and you can in theory you can just create all the CGI work all here in Creo. Don't go straight to CAD. For this, what does this mean? This means like if you have some design in your mind, the first step is not CAD. It's again that old pencil and paper. Just try to visualize it, just try to draw some freehand sketches and to see like what dimensions are. Unless you exactly know the dimensions, obviously you know all the constraints your design is having. Unless you don't have those details, you are bringing up a new design, it is not preferred to go straight to CAD. And it is preferred to first make a free hand drawing just to visualize what your stuff is going to look like, and then go to CAD. And you're going to realize why is that just in a moment when I start making some things, because sometimes it's hard to visualize the final product while you are working with CAD. Again, use it at the right time. Also, this is the most important thing, and this not just stay with CAD, or it is something which you can apply to like any of your other subjects. Always question your results. Don't try to get sense out of them. Ask your results if they make sense. If they don't feel right, they may not be. Like many times, if they don't feel right, they are usually not right. So always question your result outputs. Oh yeah, these images. You can also do some basic simulations in Creo. You can design these and simulate some basic structural simulations and in Creo. Yes, you can do that, but again, it is not, Creo has not its strengths, or even SolidWorks doesn't have its strengths in simulations or mathematical modelings. For that, you would have to move to Abacus or ANSYS or any software like that. In my experience, if you want to work more towards simulations, like if you want to export your models into different other softwares, Creo works the best rather than any other softwares. But if you have just to design stuff up, then obviously there are other options too. So Creo basically works on two basic rules. One of them is like parametric modeling, and the other of is like kinematic modeling. So let's talk about parametric modeling for now. How we work on any CAD software is like we build up some parts. Before making parts, we make their drawings, a 2D sketch. Then that 2D sketch converts into a 3D part, and then parts combine to form assemblies. Sketch, part, and then assemblies. And then assemblies can be done with kinematic modeling. So so if you made several parts and then combine them to form an assembly, and then you go back and then you realize, okay, this one part is not fitting up in the assembly and you have to change it, you can simply go back to the root, the sketch, and if you change it over there, the change is going to be persistent all across your assembly. So if you change the base sketch, the part which is dependent on that sketch is going to change, and that part which is being used in assembly is going to change. That's called parent-child relationship. So if you are going to change the parent, the child is going to change. And once you have the assembly, obviously in the Creo or any other CAD software, you can visualize their movements. That's called kinematic modeling. Using kinematic modeling, you can see if the parts are getting meshed together properly. If you have some gears, are they moving properly? If they are meshing properly, how they are interfacing with another part. If there is some movement, is there something which is hindering that movement? This all things you can do inside the Creo. So that was a minor presentation. And now let's talk about how you can install Creo on your own PCs, or how can you use Creo. So now you have two options. Either you can download your own personal copy, or either you can use the online VMware which is provided by the university. Let's talk about getting Creo on your own PCs now. Creo only works on Windows interface, Windows operating system. It is not going to work on any Mac OS or any Chrome OS or any other operating system. So if you have a Windows PC, the things are really simple. Either you can download a student copy from PTC website. So simply you are going to go to, you can search PTC student and you would get this link. You can go over here, register, and then they're going to send you a PDF file with your registration, with your installation guidelines. Just follow them up and you will get your student copy. Just download the latest version you can. For people who are working with any other operating system, and let's talk about system requirements first, then we are going to go towards other operating systems. In my experience, anything with greater processor than i3 and 8 gigs of RAM is going to work fine with Creo. At least the basic Creo which we are going to use in this semester. And yeah, that's pretty much it. Like, and any i3 or more with 8 gigs of RAM or more is going to be fine. That a window would open up and they might ask you for access or like firewall rights or things like that. Just allow that, and a window like this would open up in front of you. You can just close this window down. It's just a CAD browser. You don't need that. We would be working on models later on in the next sessions. Over here, you don't need to worry about if you cannot replicate what I do. You just need to observe, and you can just try to play with the software and just see what you can do. The first thing which we need to do is to tell Creo the place we are going to be working in. That's called working directory. So if you don't set a working directory in the very start, your files are going to be saved uh, in your C drive somewhere, and later on it's going to be difficult for you to find them where they went. And especially if you're working on like a complex project in which you are making different assemblies and then adjoining those assemblies, you need to know like which part is which. Then it's always better to create working directory, new working directory for everything new you are creating. This is the step which you always would have to do when you open up a new Creo window. So let's do that. So in the top pane, here's the point, which is saying that select working directory. If you click on that, it would open up a new window. I already have a folder made, but you can always just right click and make new folder. Let's create a new folder. So you just right click, create new folder, name it as whatever you want to. Just click OK and click OK. That's done. Your working directory is already set now. So if I want to change that, or if you want to see that, I can just click on select working directory again, and if I want to change it, I can change that. So always set working directory before you start working. And then when you are all set and you are ready to start the work, you can always click on new. Now when you click on new, you would see that you have many types available over here. Sketch, part, assembly, manufacturing, drawing, format, notebook. We are going to be staying to sketch, part, assembly, and drawing mostly in these sessions. The sketch module, it just works in 2D modules. Like if you need to create only 2D drawings, you can use the sketch mode. For example, if you have some shop floor drawing and you want to replicate that as is, you can use this mode. In the part mode, you create 3D parts, single parts. Again, this is not going to be assemblies. And the assembly module, as the name suggests, you combine different parts to make assemblies. And in the drawing module, we create 2D drawings with all the details and all the dimensions which we require, like you can say shop floor drawings or manufacturing drawing, or how they are called technically is engineering drawings. Generally, when you know CAD, you never use sketch mode. Generally, you always go for the part mode because the part mode has the sketch mode incorporated in it. We are going to be using sketch mode in the next session. For now, I'm just going to give you a basic overview of what this thing can do. And I did one mistake. I didn't tell Creo that what system of units are we working in. So let's just close it down and let's just start that again. It would take a couple of minutes to start up. Okay, so new part, and if you want to tell them like what units you have to work in, you have to uncheck this use default template, and over here you can give your file any name. And then when you click OK, it would be a new window. And all of these units which we are going to discuss later on in the coming sessions. I am choosing millimeter Newton seconds. Now in the 3D, in the part mode, you would have a 3D window available to you. In the sketch mode, you would have a 2D window. One thing which I would like to mention over here is, while working with CAD, you would need a computer mouse with a scroll wheel. The trackpads, it's almost impossible to work with CAD with that laptop trackpad. So how I'm rotating this is like keeping pressed my scroll wheel and just moving my mouse. You we will be doing some drop-in sessions, and you can ask us if you have any queries about these things. So let's just try to make something. If I'm just making some random things over here. If you like, you don't need to follow my commands. I'm just trying to show you like whatever you can do over here. Let's make a circle over here, and let's extrude that to make a hole in this thing. Maybe you can round these corners, or we can place some holes over here. Let's not make it this one a through hole. Or you can use some chamfers in there really easily. And we can also shell it if we want to. So CAD softwares are usually, again, these are machines. They're going to do whatever you are going to tell them. And sometimes for a CAD software, reality is what you tell it. For example, if I look at this more closely, I have created a shell over here and there is nothing down over here. Maybe this is not engineeringly feasible. So you cannot trust a software with intuition. Intuition and the thinking is going to be yours, and software is going to do whatever you tell him to do. And obviously we can always save this. Okay. And you can always open new things up. Let's try to do that. Let's try to open up this thing. So I made this part a while ago, and if I want to, like, again create a drawing for that, I can do that. Let's just go randomly for it, and let's just increase its scale from and as you can see, like, you would not have to do much to create the dimensions again. So once you have done that, once you have made a model perfectly, your work would be much easier. You would not have to repeat anything over here. By the end of these sessions, we aim that you should be able to make good assemblies, good parts, and good drawings which are engineeringly sound, by your own self of your own designs. So before the next session, I need you guys to have sorted out how you are going to use a Creo on your own machine or in the machine in the university, like wherever you are going to use it. You should have like sorted this out. You should know how to set a working directory and how to open up Creo. And then we are going to move forward from that point onwards. Happy learning, guys. Bye bye.